Hi, my name is Lee Gui Hong, and today my team and I will be presenting on our distributed computer system project titled Smart Pharmaceutical System. First, I would like to start with the background of our system. Now, before we get into the smart pharmaceutical system, we need to know about pharmacy itself. While people may think that pharmacies are places where people go and buy their bandages, Panadol, and their Sensodyne toothpaste, a lot of people actually get their prescription medicine from pharmacies, especially those that require long-term medicines or they have to get a weekly or monthly top-up. Next, I would like to talk about who are the people that run these pharmacies. They are called pharmacists. Right. Now, according to the Oxford definition of a pharmacist is a person who is professionally qualified to prepare and dispenses medical drugs. Now, basically, they are health professionals who know the composition, properties, and the proper use of medication. At the same time, the pharmacist provides pharmaceutical information and advices to the public, as well as some other primary healthcare services. So basically what would happen is the patient would go to the pharmacy with the doctor's prescription, and the pharmacist will give them the medicine and teach them how to take their medicine. Next, I would like to talk about the COVID-19 pandemic. As of the 30th of August 2021, there has been around 1.71 million cases of COVID-19 and more than 16,000 deaths in Malaysia alone. In order to contain and curb the pandemic, the Malaysian government has implemented various movement control orders. Under the movement control orders, all social activities and gatherings are prohibited, and all stores are closed except for those that are deemed essentials. People have started to work from home, and students have started to attend online classes. Suffice it to say, this pandemic has changed the way we live our lives. Now, the COVID-19 pandemic has also caused our medical infrastructure to be overwhelmed and caused patients with other illnesses to face the problem when getting treatment. Visiting places like hospitals are also considered high risk for patients, and those who visit sometimes have to spend sometimes hours trying to get swab tested, which sometimes translates to long waiting time in the hot Malaysian weather. One way to relieve some of the stress from our hospital is by diverting some of the patients to retail pharmacies. Another effect, or rather cause of the spread of the COVID-19 pandemic is that there is a lot of widespread misinformation of the pandemic and other health information. Whether it's from your mother's WhatsApp group or the health minister telling people that drinking warm water prevents the virus, it is certainly one of the biggest obstacles in fighting the pandemic. Now, there is a solution to all this problem, which is smart pharmaceutical system. Now, here are some of the features of our smart pharmaceutical system and how it could be used to solve some of the aforementioned problems. The first feature is a web page that would display relevant information to the patient and user, which would hopefully help clear up some questions and doubts. This could be a very good way to fight misinformation. The next feature is an automated chatbot, now which would allow user to make an appointment with the pharmacist. This could help customer avoid waiting long lines outside the pharmacy and make sure that they'll be able to meet the pharmacist. Sometimes the pharmacist might be out for lunch, sometimes they might not be at that particular pharmacy. Now, for patients that have a higher health risk, the system can also collect the data of patients and would notify the pharmacist if there are any irregularities. The pharmacist can also give some basic medical advice based on the collected data and of the customer and the patient. And that would be all for my part, and now I'll pass on to my next teammate, Zing. Thank you.
Thank you, Gui Hong. My name is Yamzing. So now I'm going to talk about what has inspired us to build this smart pharmaceutical system. We know that in this modern age and day, most of the people live in a very fast-paced lifestyle, especially for those who are living in the big cities. They are always too busy to cope with the high working pressure and competition. This phenomenon leads us to neglect our own health and tends to ignore the disease symptoms that happens on our body. I believe that most of us will choose to assume those small symptoms that happens on our body are minor illness that will eventually recover. And this action is actually very dangerous as we might be putting our lives at risk. Because by the time we have started to realize its seriousness, it might be too late. So, this has motivated us to build a smart pharmaceutical system that focuses on providing treatment to patients efficiently. There comes the problem statement of our system. People who do not feel well or have any health-related inquiries are able to access the smart pharmaceutical system for help anytime, anywhere. People who would like to ask for health consultation can make appointments through the system's smart chatbot. Then it will automatically help them to check for available slots and set reminders for them once the consultation slot has been confirmed. Making appointments through the smart pharmaceutical system is far more efficient and accurate than walking in or through a phone call. By implementing the IoT (Internet of Things) feature to the smart pharmaceutical system, we can automatically record the patient's health status. Once the patient's health condition has been detected to fall far more than from normal to be abnormal, they will be alerted instantly to take emergency medications or seek for help from the pharmacist or doctor. Thus, the health tracker feature of the smart pharmaceutical system could prevent many tragedies from happening before it was too late. Besides that, one of the main reasons people with sickness nowadays are not willing to see the doctor is because they think traveling to the clinic or pharmacy to seek for health consultation or minor issues is very unnecessary. This could be time consuming and money wasting. Therefore, the smart pharmaceutical system can help patients to resolve this problem by providing them basic medical advice online on minor illness via the chatbot. Furthermore, the extra advantage of this smart pharmaceutical system is that it can collect the health data from patients automatically, which provides more precise visualizations on the health condition based on different groups. Depends on which groups do the doctors or pharmacists want. For example, age groups, and yeah, age groups. Therefore, it can act as one of the big data collection methods which help health consultants, doctors, and pharmacists to give advice and medication based on the patient's personal information.
Thank you, Zing, for explaining the problem statement. My name is Ken White, and now I will talk about the literature review. As we know that in 2021, cloud computing has become the standard approach for information technology. Cloud computing has been around since the early 2000s and have been a major change to us. And so what is cloud computing? Cloud computing is the delivery of computing services, including servers, storage, databases, and more services over the internet, which we call it as cloud. And here are some reviews of some top cloud service providers. Amazon Web Service, also known as AWS, is one of the top cloud service providers. AWS is an Amazon subsidiary and began to provide web services in 2002 and launched cloud computing in 2006. And for now, 2021, AWS has over 200 products and services, and some of the featured products are Amazon S3 for storage, Amazon EC2 for cloud computing, DynamoDB for database, and more. AWS offers pay-as-you-go approach for pricing over 160 services, which means you just have to pay for the services you use. And next, we have Google Cloud Platform. Google Cloud Platform was launched by Google in 2011, and it is intentionally to strengthen the Google products such as YouTube and Google Search Engine. Google Cloud Platform has over 100 products and services available, which some of the featured products are Compute Engine, Cloud Storage, Cloud CDN, and Cloud SQL. Just like AWS, Google Cloud Platform also offers pay-as-you-go approach for pricing. And lastly, we have Microsoft Azure. It is offered by Microsoft in February 2010. Microsoft Azure has over 200 products and cloud services available, and it is accessible in 140 countries and is offered in 54 regions across the world. And yes, Microsoft Azure also offers pay-as-you-go approach. And these are the literature review of the top 3 cloud service providers, and I will now pass the presentation to Jason to talk about the objective of this project. Thank you.
Thank you, Ken-Y. Hi, I'm Jason, and I'm going to talk about the objective of our project. The main objective of our project is to create a smart pharmaceutical system using web-based technologies. We can first divide the system into two main parts. First is the pharmaceutical chatbot system, and second is the smart system. The idea of creating pharmaceutical chatbot system is to improve the overall efficiency, interaction efficiency between patients and pharmacists. And the idea of creating smart system is to receive patient medical readings and perform analysis on those readings. So the objective of the first system, which is the pharmaceutical chatbot system, is to handle patients' enquiries, such as any health enquiries. And the second objective of that system is to manage patients' appointment details. And the objective of our smart system is to receive patients' health readings, such as blood pressure level, and BMI weight, and other medical reading. And the second objective of our smart system is to notify pharmacy about patients' health conditions, whether or not the patient is in a healthy state, or whether or not the patient is entering towards a non-healthy condition. That's all about our objective. I'll be talking about the proposed solution next. Thank you. Now I'm going to talk about the proposed solution of our project. So this is the proposed solution of our project, the whole diagram, our smart pharmaceutical system. We can split the system into two parts. First, on the top is the smart system in the blue highlighted bracket, and the bottom red highlighted bracket is our pharmaceutical bot chat system. Each of the system we use several web services from Amazon Web Services, and now I'm gonna talk in details regarding each of the services in each of the system. So in the first system is the pharmaceutical chatbot system. The first component or web services we use is the Amazon Lex. Amazon Lex is used to provide a chatbot service, and the main function of Amazon Lex in our project is to respond to patient enquiries and request appointment details from patient, such as patient name, appointment date, and appointment time. Other than that, we also use AWS Lambda in our chatbot system. The AWS Lambda is responsible for transmitting appointment details from Amazon Lex to Amazon DynamoDB. Other than that, AWS Lambda also is responsible for sending notification signals to Amazon SNS. The third component that we use in this system is the Amazon DynamoDB. The DynamoDB is responsible for storing all the patient's appointment details and maintaining and updating all the appointment details real time. The fourth component that we use in this system is the Amazon Cognito. Cognitor provides identity and authentication towards the patient so that the pharmacies and the system will understand their identity and understand who is the patient. The fifth component is the Amazon CloudFront. Amazon CloudFront is used to provide the web content of the pharmacy page, which allow patient to view the medical data, the products of the store, and also to access towards the chatbot system. And the last component is the Amazon S3. Amazon S3 is responsible for storing all the web content information such as images and text and videos for the CloudFront to display towards the public. And moving on to the next system is the smart system. In the smart system, the first component is the IoT core. The IoT core is responsible for keeping tracking the medical devices from the patients and also was responsible for transmitting patients' medical data from the medical devices towards the database. The second component of this smart system is the AWS Lambda. The AWS Lambda has a different function as comparing towards the AWS Lambda in the pharmaceutical chatbot system. The AWS Lambda in this system is responsible for transmitting patient medical data from DynamoDB to the Amazon Athena. Amazon DynamoDB in this system is responsible for storing patients' medical data. And the fourth component of this system is the Amazon Simple Notification System. Amazon Simple Notification System is responsible for sending notification message to the pharmacists whenever they receive a signal from IoT Core or from the AWS Lambda in the pharmaceutical chatbot system. The fifth component is Amazon Athena. Amazon Athena is responsible for analyzing data using standard SQL. Through using Amazon Athena, we can have a better categorize and group data, which is easier for the pharmacist to understand and analyze the patient's data. And the last component is Amazon QuickSight. Amazon QuickSight provides a better data visualization through using interactive dashboard. This allows the patient to have a better view and have an easier view of the overall data. So this is all from me, and I will pass to Ziying for the future work presentation. Thank you very much.
Thank you, Jason. So after we have talked about how our system works, now it's time for us to introduce the future work on our system. Although the smart pharmaceutical system that we have worked on consists of many features that manage to bring conveniency to our users, there are still many improvements that we can make on it in the future. One such example is that the feature to notify customers when to take their medicine. This feature might be helpful for forgetful people, especially the elderly, so that they would not skip their medication which might worsen their illness. Besides that, the online consultation feature that we have been working on can also be improved by implementing live customer service. The live customer service feature allows users to contact the pharmacist for health consultation online via the chatbot. Hence, patients are able to get consultation on more complicated health issues which the chatbot itself cannot answer. This feature is beneficial for people who have problems traveling to the pharmacy or clinic. For example, people with disabilities or elderly who have mobility problems. Moreover, since the smart pharmaceutical system built is just for web application, it is considerable to make our system accessible via mobile application as well in the future. With the help of mobile application, our system will be more convenient for users to access as mobile phones can be carried anywhere. The system is also able to send messages and alerts to users via notifications instead of email or short message services. Last but not least, it would be great if the user interface could be updated to be more user-friendly. Since the main concern of us on building this system was on its operation, we do not focus so much on the user interface design. Therefore, the modifications can be done to make it friendlier and easier for people to use. Yeah, so the user interactivity can be improved too. That's all from me, and now I'm going to pass the presentation to Kenwai. Thank you.
Thank you, Zine. Now I will be talking about the comparison of relevant cloud technologies that used in the project. AWS, Microsoft Azure, and Google Cloud Platform will be used for comparison in this section. For serverless computing, AWS uses Lambda, Microsoft Azure uses Azure Functions, and Google Cloud Platform uses Cloud Functions. And for this, Lambda offers the best at managing workloads with the ability to manage up to 1,000 functions concurrently. For NoSQL database, AWS uses DynamoDB, Azure uses Cosmos DB, and Google Cloud Platform uses Google Cloud Data Store. DynamoDB is the best in terms of price efficiency and the strength of the surrounding provider service ecosystem. It enables features like strong consistency and transaction to provide flexibility. For cloud storage, AWS uses S3 bucket, Microsoft Azure uses blob storage, and Google Cloud Platform uses cloud storage. And for IoT platform, AWS uses AWS IoT Core, Azure uses IoT Hub, and Google Cloud Platform uses Cloud IoT. And in this case, IoT Core is able to accommodate billions of devices and trillions of messages, which is tremendous. And for messaging, AWS uses SNS, Microsoft Azure uses Azure Notification Hub, and Google Cloud Platform uses Firebase Cloud Message. In this case, Azure Notification Hub offers more flexibility. Analytics, AWS uses QuickSight, Azure uses Power BI, Cloud Platform uses Google Data Studio. And in this case, all of them are equal. However, AWS has an autograph capabilities that suggest graph style to be plotted. CDN, Content Delivery Network. AWS uses CloudFront, Azure uses Azure CDN, and Google Cloud Platform uses Cloud CDN. Amazon CloudFront and Azure CDN are more developer-friendly as they allows developers to customize features and support API respectively. Chatbots, AWS offer Amazon Lex, Microsoft Azure uses bot service, Google Cloud Platform uses Dialogflow. All three platforms provide web interface to create and launch bots. In terms of language support, AWS only support US English, while Azure and Google support multiple languages. So these are the comparison of the relevant cloud technologies we use in this project. And this is the end of our presentation. Thank you.